Hello everyone, I am Necmettin Gedikli. Welcome to my linked list sorting algorithm program with C++. Today I'm going to show the code I wrote about the sorting the linked lists, and I'll try to show this algorithm's logic with the diagrams. And let's start our video. This time I'll take it simple, and I am going to focus on the diagrams. As you can see, uh, these are the diagrams I drew out for the explaining the code. And let's start out from the main block. As you can see, I created a object called Necmettin uh, related to sorting algorithms class, and I created a simple uh, user interface. Uh, there's no important thing here. Just adding a note. I'm adding notes from here, student notes, and I created a while loop for this default section. If I press a email section, uh, we are going to get back to this while loop, and until we're gonna select the true case. If we press 1, you're gonna execute the bubble sort method. If you press 2, insertion sort. If you press 3, selection sort, and so on. That's it, by the way. Not so on. And let's get our inside of the class, the beginning of the program. And I included the CC type library for converting the lowercase gender acronym into uppercase, because we're gonna use the we're gonna define genders with uppercase letters. I created the sorting algorithms class here, and I created private section with the structure called student. Here there are the variables related to which belong to student structure. And here we defined next pointer as well, and uh, length and quantity for the declaring the number of the students, and head and tail for the declaring the head and tail of the linked list. And on the public section, we created our constructor on here. uh, it's pretty simple, by the way, and we are adding nodes on here. If the quantity is 5, we're gonna add append 5 students. Like, as you can see, here's the gender acronym, and on here we are making it into uppercase. And on this side, we are appending our new student node, and next pointer will be the null because it's the last node. There is no node on the front, and if our length is equal to 0, head and tail will be the single node. And if it's more than more than 0, this time our tail will be changed with this code section. And here, as you can see, we got the bubble sort. And let me explain the program like in this diagram. First, imagine that this is a common case. We created 3 variables: student q1, student q2, and student q3. And on the student q3 and q2 and q3, uh, as you can see, 2 is the 26 and 3 is the 20, and we have to change them because of the bubble sort logic. We have to swap them. And on the side, our q2 will point the next one, which is the q3's next node, and q3 will point the Q2, and the Q1 will point to Q3. And when we arrange it, as you can see, Q1, Q3, and Q2, 15, 20, 26, and 30. And when we arrange it, we have to put the Q3 after the Q2 for making the process into next step. And here's the last result, and here's the code. And in this site we are moving to the next nodes, Q1, Q3, Q2, and Q3. And on the insertion sort side, uh, let me explain it with the diagrams as well. As you can see, we created a dummy node which is empty, and but it will show the head. Okay, and on this side we have head, previous, current will come after the previous. And on the next step, as you can see, previous and current is here. uh, Previous will always behind of the current, and uh, current is 3 and previous is 4. In this case uh, we have to take this current value, and we have to compare it from beginning to end, this until the previous node, but previous is included. And after this process, as you can see, our current is here, and our previous will show this node with the age 5 value. And after this step, we are moving this current into the next node, uh, previous next node. And here's the insertion sort, and as you can see, here's the code. But we have to create dummy node, because if we don't, we're gonna stuck on a particular step. And we also use temp as well for changing the manipulating next pointer values after swapping. And in this side we are moving to the next nodes, and on this side we got the selection sort. It's too complicated when we compare with the other sorts on the linked list, and let me explain it on the last diagram. Selection sort, as you can see, we will have dummy node again with the border and the temp, and our current and small will start from the head. This is the head node, by the way, because the dummy is empty, and dummy will always in the starting point, dummy will always point the head node. And after this case, we're gonna get the current will be 1, and small will be 3, because small will start from this first node, and until reaching the lesser value, which is lesser than the 3. As you can see, it's 1, by the way. There is a 1 value for the which is lesser than 3. And after that, we are changing the next pointer values, inserting this first value with the new small value. And as you can see, small will point the temp holder. This temp holder will be created because of the storing the date of the last temp value for the storing the related to last small value, because temp is always changing. So that's why I created a variable called temp holder for storing the last small case. This small will point the temp holder. This 3 will point the small next. This is also storing the storing the address which comes right after the small, and the dummy will show this new small value. And so after this case, and by the way our current is right now null, uh, this this iteration will resume until current will be the null value and temp will be the last node. And on the last drawings, as you can see, we move the border, and the temp will be here as well, and it will start from the this time current as start will current and small will start from the this node, which is age value is 2, and this is the border. On the border will start from here, and after the steps, it comes from there and there and there until we have two swappable nodes. And on the, as you can see, here's the code. We created the temp holder and small next address for storing the pointer address. For manipulating next pointer values, as you can see, I added so many comments on here. If you want to check the code, you can uh, pause the video, and it's hard to explain it, by the way. uh, as you can see, here's the code, and on the last step, we have to move the border, and we're gonna make uh, current and the small values from the border's next node. And on this last side, we are rearranging the head node, which is comes right after comes to dummy's next value. And on the print side, it's so similar the previous video I explained. It starts from the head node, and until the tail. A tail is included, by the way, but on this side we have no tail right now. We declared in the first of the program, but after manipulating the pointer addresses, our uh, our tail's location is somewhere else, I can say. But we're gonna start from the head until our this student node pointer will point to null. Okay. And you can see I'm printing the informations about each student nodes. And on this side, yeah, we came back to our main block. Here's the code, as you can see, and that's it. Thanks for watching.